Hey,
Hey, everybody.
Here we are.
Yep.
I'm looking to see what the time delay is. Might
It seemed like
30
about
seconds
10 seconds. How much would you say?
I don't know.
I said 10,
hello.
but it's probably nowhere near it.
Hello. Welcome.
Welcome.
We haven't seen anybody. We haven't seen anybody since a whole year ago.
No, man. Last time we saw everybody was the last freaking year.
Man, we're in a whole new era.
Yeah.
One would hope. Anyway.
Yeah.
Hey.
Well,
hey.
we're definitely in a whole new era with telescopes, maybe.
Yes, we are. So it's good to see everybody there in chat. Jack, Adam, Brandon. Oh, half his family says hi. Oh,
what?
No. Oh, now don't tell us your family's watching. Oh gosh, I'm nervous now.
But it's only half of them.
I mean,
Why do we not have the other half?
I don't know.
Do they not like us? What's the deal? All right.
Yes, Brandon's wearing his cloak of invisibility.
Yeah.
Joining us from
not on assignment. He's actually
he's
just visiting
spending time
family.
with his family because people are allowed to do that, and we'll allow it, I guess, even though he's never here for anything.
But your mom's watching the Royal Canine Dog Show.
Daughter's online podcast. That's it goes nowhere. Dog show. I mean, it's a dog show. Anyway.
But they have the working group that's coming up.
You gotta work it. Those dogs. You gotta work it. All right.
All right, we're gonna do this.
Who's hosting?
You're hosting.
Oh, I'm hosting? Okay.
I hosted last
thought
time.
Maybe I was hosting, but I wasn't quite sure.
That's why it says Liz up there.
All right. Okay. So, gosh, if only I had somebody here to give me a countdown.
What is it? 5, 4.
Hey everyone, welcome to Cosmos with Cosmos. I'm Liz.
I'm Mike.
I'm Brandon. We'll have the ghost of Brandon during this episode. It seems. He's going to be talking to us through the ether.
Through the ether or chat, whichever is easiest.
Yeah, but if you're listening to the podcast and just listening to it, you can't see him.
Yeah, anyway, so but he's on vacation. He's spending well-deserved time with his family.
Yes. Which sucks for him because we're doing a James Webb Space Telescope recap because it made it.
So far it has made it.
It's launched.
It is up
successfully.
There. And we watched it.
We've all at the crack ass of before dawn, Christmas morning.
At 4:20 in the morning Pacific time, we got up.
My sister actually woke up.
Your mom and dad did as well.
I was very surprised, and I was very proud of you, Katie, for getting up.
There was only one person in the house who did not get up for
okay.
it. We will not mention Adam's name at all in this. But no, it went up, and it was so exciting.
Yep, even Dad got up. He's very interested in it. Yeah, and he really likes the website that you guys can follow along with James Webb. The James Webb tracker. I don't know what it is. It just NASA's.
You get to it through
jwst.nasa.gov.
Yep.
And
tells you exactly how far away it is, how much further it has to go as far as miles.
Yeah.
Even gives a percentage of how far it is and its speed and temperature.
Yeah, so
the temperature is really important for it.
It's really cool. So check that out. Before we get too much into everything and the celebration and the things that it's doing and what's going to happen, we have our drinks.
We do. We even have Brandon's drink name.
We have Brandon is drinking a honey hexagon.
We don't know what it is.
We don't know what it is,
but it sounds really good.
It sounds beautiful, actually.
It sounds like it has honey.
It sounds...
It
sounds beautiful. It's probably like honey and bourbon. I don't know.
He could text us what's in it, or he could put it in chat.
He will, yeah.
And
it sounds beautiful.
Yeah, definitely.
What are you drinking?
I am drinking 10 billion and worth it.
Yeah, spend that money.
Spend that money. Definitely worth it.
Budget.
Yeah, but that's okay.
It's worth it for
it is definitely
science
worth it.
And progress and The universe.
And my drink has whiskey, gin, amaretto, and orange juice.
That's a lot.
That's a lot.
That's a lot.
I might not make it to the hangover, but or I might have a serious hangover during the hangover.
Yeah.
But we're gonna try.
Meanwhile, I am drinking what's being called the Halo, and it's amaretto vodka.
Amaretto, vodka, cranberry juice, and orange juice.
There we go. So it's the Halo.
Yes. And why is it called Halo? Oh, and by the way, Jack says that he has a site up on a kiosk at his planetarium.
As any good planetarian should.
Mm-hmm.
And thank you. This shirt is a Christmas gift from a mom. Also a Christmas gift from a mom. So my mom knows how to buy us space shirts. She's very good at it.
Yes. As soon as this came out of the gift, it was like, oh, well, I did wear it that day.
You did wear it that day.
I did wear it that day, and I'm like, oh, this is completely...
And yeah, I even got him like a Gandalf shirt that's like Led Zeppelin's... I
have worn all my Christmas shirts.
I know, but I'm saying that was the one you chose to wear the day of receiving. So
yes. I'm sorry, but
I mean, it's James Webb. It's fine.
I did read the Kindle a lot.
Yes, I got him a Kindle. He's reading.
All right.
Jack's drink is a white chocolate and mint latte, double shot of espresso. Yes, get hyped up.
Yep.
Gotta get that caffeine going. Speaking of drinks, we have some drinking rules to go along with the show, of course, because why not? If you hear the dogs barking, you can take a drink. If you hear your own dogs barking, feel free to take a drink. We won't hear it, so we won't know and won't take a drink with you, but you can do what you want.
Yep.
If we make any Star Wars or Lord of the Rings references, take a drink as well.
Yes. You know what I think we need to do? Speaking of drinks, we need to make a toast.
Oh, yes, I was going to get to that.
Okay. I'll let you do it.
But since we are here talking about James Webb Space Telescope, it had a successful launch.
And deployments. There's, everything so far is deployed successfully.
Everything's been good, so we're going to have a little toast because we have leftover champagne from New Year's. A toast to James Webb.
The James Webb Space Telescope.
Cheers, JW.
And keep deploying. Oh, yeah.
Keep working.
Please keep working.
A fun tidbit that Brandon shared with us, though, last night, was that they did remember to remove the lens cap.
That's
very important in any kind of photographic work.
Yeah, you definitely...
And science. You want to remove that lens cap. Especially when that lens cap cost part of $10 billion.
Yeah, almost 9. It was, what was the cost? It was total cost is $9.7 billion. 8.8 of that was for design and development.
Whew.
And then you get into $860 million just to run it for the next 5 years.
But James Webb, it's like one of the most technologically advanced.
Oh, it is by far.
Feats of engineering that we've done as a species.
Yeah.
In all of humanity.
And they have to do that. It's going to be 1 million miles away.
Yeah.
It's not like you can send an astronaut up there. The best we can do right now is send an astronaut to ISS. We can't make it out.
Well, there's nowhere to live. Miles. There's nowhere to live further out. There's no
Not yet,
way
anyway.
station.
Not yet.
No, I mean hopefully one day.
We have to. We're going to have to go further than that 1 million miles, though.
Eventually. All right, so James Webb, studying every phase of the universe's history.
From Big Bang to today.
Because they can't go before the Big Bang.
No.
Yet.
Yeah, well, maybe also you can't go beyond the cosmic background.
Oh yeah, well that's
so
yeah.
Everything from the glow until today.
I don't know what drink to drink now. I guess I'll work on the champagne first.
That's what I'm gonna do.
Get those bubblies in my tongue.
We gotta pace ourselves.
Yeah, I know.
But especially me. But anyway, so it's going to study the universe in the longer wavelengths of the visible spectrum, so red light. But it's also where its real power is in the infrared. Yeah, and so it will be studying the near and mid infrared. And what does that allow us to do? It allows us to search for light from the first stars of the universe and galaxies that formed in the universe shortly after the Big Bang.
For those faint, early, distant glows.
Yeah, well, that's well done. That's well done. It also allows astronomers to study the formation of galaxies.
That's fun.
Because that is actually a big kind of mystery, is how do galaxies form? And, we see all these beautiful galaxies out
I
there.
just figure over time, you got areas of denser material that just eventually kind of, as they're coming together, they're forming stars and shit, and eventually just kind of clump up.
Yeah. Well, I mean, that's pretty much it. But
and you have things moving, so you get arms that are kind of like, wee. But then sometimes you don't have any arms because maybe their arms, after a while, we're just like, all right, we're just sick of this. We're just going to... I don't know what I'm talking about.
I'm just going to let you go.
Okay.
Well, yeah, I mean, so they think that the galaxies built up from mergers of galaxies, but you kind of need to look through a telescope and
that
prove
seems
that.
a little chicken and the egg right there, though. You need to have a galaxy first
that's
before
true.
you can merge into a galaxy to make another galaxy.
Yeah, little baby galaxies. Bumping into other galaxies. Making other galaxies.
The galaxy bump. The horizontal galaxy tango.
Wow. Galaxy sex. That's what we've devolved to.
Yeah.
But it also is going to allow for the understanding of the formation of stars and planetary systems, and then to study the actual planetary systems themselves, and maybe the origins of life. Who knows?
It's just going to be like the best eyes we've had. The best.
Oh yeah, I mean, when we think of telescopes, right? We think of Hubble.
Yeah.
And the power of the Hubble Space Telescope, and if let's be honest, if James Webb deploys everything successfully and does what it's supposed to do, then bumping black holes, and then
they go bump in the night.
And then I forgot what I was going to say. What was I talking about? Oh, if it deploys...
Yeah, sorry, we went down that glory hole.
Wow. Okay.
Okay.
I
forgot Brandon's family's watching. We gotta be on our best behavior.
I truly forgot what I was going to say, so let's just move on.
It's studying planetary systems and the origins of life.
Well, yeah. And if it all deploys everything successfully, it'll be 100 times more powerful than the Hubble Space Telescope. Yeah. And it's going to work in concert with the Hubble Space Telescope.
Until Hubble can't
you're right.
go any longer.
Because the Hubble Space Telescope doesn't work in the infrared. Well, it does a little bit, but not like James Webb. And so when the Hubble Space Telescope took a picture of the Hubble Deep Field, it found the most distant galaxy that we know of.
Yeah.
James Webb's going to be able to appear beyond that.
Yeah, because it can see.
Yeah.
More broadly with infrared.
And more broadly, exactly. And when you look at objects that are shining in infrared, one of the things that you're going to be able to see are these galaxies that are moving away from us extremely fast. So fast, in fact, because they are so far away from us and their light has been stretched out, redshifted to the infrared, out of the visible into the infrared, and we're going to be able to see them.
That's cool.
So
we're going to be able to see so many more things than we can... Why do we keep doing this? Than we can see now.
Right, we're only 13 minutes in.
You know what? This is why I don't drink out of like wine glasses with a stem. That's why I need stemless, because my hands just go everywhere.
Yeah, I know, right? We don't drink out of stem glasses. All right.
My mom says, by the time we get out there, things will look very different, right? By the time things get to Earth, we're seeing things that happened in the past.
Exactly.
Basically, the things that we're looking at now, that we can see now in space. I mean, even something as close as the sun, it takes 8 minutes for that light to get to us. So essentially, when we're looking out into the universe, which is one of my favorite, most romantic things about the universe and space, is that we're looking back in time. We're time traveling with our eyes. We won't know, what, the conditions of a planet or a star that's, say 20 light years, say 2,000 light years away. what it's like right now until another 2,000 years ago when that light finally
Right.
reaches us. So
Right. Yeah.
it's like,
You know, we should do a show on
I do need a sippy wine glass.
sippy wine cup. Yeah, I mean, we should do a show on just like time travel through telescopes. You know, just looking at the moon 1.5 seconds ago, looking at the sun, which don't ever look directly at the sun. 8.5 minutes.
We can never see anything as it is
No,
right now.
even with Liz sitting right next to me, I am looking at her as it was in the past. I mean, it's extremely small.
Micro.
Yeah, I mean, it's like a
micro
nanosecond. It's like nanoseconds, but it's kind of like this podcast. I'm looking at you in the past. They're looking at us. I mean, there's time delay.
Yeah, the time delay. That's actually a good. Oh, thank you. Thank you, Jack. But I don't know why you need to wait all the way to my birthday.
That's your Valentine's gift.
Oh, there you go.
Here's your sippy wine cup.
Thank you. I need that. All right, so it's gonna study a whole shit ton of things that are gonna be revolutionary, groundbreaking, new stuff is gonna come our way. And we have it partnered with NASA, ESA, and CSA.
Canadian Space Agency.
You don't get a lot of the CSA.
No.
In these kind of things, which I was like, oh.
I bet we do. But I mean, it's just Canada. It's just the 51st state, right?
Yeah.
So.
But I mean,
we've lost the whole country.
It's just like I didn't realize French New Guinea launched rockets, like that it had a spaceport basically.
Well, yeah, I mean it's.
I was like, wow, I didn't know that there was like space
is,
exploration infrastructure.
Yeah, I mean the best thing for us is to probably launch from Hawaii. To be honest, I mean it's closer to the equator.
Yeah, but I mean.
They already
got that volcano exploding on one island. Not a lot of land room for launching spacecrafts on the other ones.
True, but you know, I think French Guinea,
New Guinea,
French whatever the country that launched it.
Yeah.
It's really close to the equator, and I think for this launch it had to be. Basically as close to the equator as we could get.
Well, yeah, because that would also be on the trajectory then of being on the plane of our solar system.
Right.
You know.
Yeah. And so now it's on its way, even though it's going to kick up above. So basically, it's going to make its way to the L2, which is Lagrange 2. There's 5 places in a 3-body problem. So you have the sun, and the Earth. There's 5 places where you could place something that is either in a stable orbit there, or kind of a quasi-stable orbit. Either way, you are not going to expend a lot of fuel to stay there. And that's why you want to get out. One of the reasons why you want to get out to these Lagrange points, James Webb Space Telescope is going to the second one, which is L1 is between the Earth and the Sun.
Okay.
L2 is on the other side of the Earth from the Sun.
Okay.
L3 is completely on the other side of the Sun from the Earth. And L4 and 5 are in front of and behind the Earth's orbit around the Sun. And so it kind of looks like, if you connect lines to all these things, it looks like Aquila the Eagle on the dome.
So it looks like nothing. It looks like just a bunch of fucking lines.
It looks like a stingray. It looks like a stingray.
Yes, a kite maybe.
A stingray. Yeah, I'm gonna go with stingray.
Yeah, all right.
So, so L2 being out there, you're in this little special place where you don't have to spend a lot of.
It's in the pocket.
It's in the pocket. It's in a special place where you don't have to spend a lot of fuel to stay there, and it will go. It will take 365 and 1/4 days to go around the sun, just like the Earth, and it'll just kind of hang out there. It's going to make. It's not going to actually be at L2, though. It's actually going to orbit it, and so.
What kind of orbit is it going to have?
It's going to have a halo orbit.
Cheers.
Cheers, everybody. It's going to have a halo orbit. In particular, Lejeune orbit. I can't. It's a French guy. I can't pronounce it. Anyway, it is. If you draw a line from the sun to the Earth to L2,
Okay.
it actually is perpendicular to that. So it looks like a big tack. Really, is what it does.
I don't know. I can't visualize it. But it's okay. You don't need to worry about it right now.
All right. So instead of orbiting around this is for everybody who's watching. And if you're not watching, just look it up.
Just hop over on YouTube and watch it.
Instead of orbiting like this around L2,
okay. I got you.
it is orbiting like this.
Okay.
Yeah.
Okay. I see you. All right.
Yeah. They're really cool.
I mean, thanks, Kepi Keps and Newton.
There's more Newton.
More Newton. More Newton.
And actually, for this, it's more Lagrange who took Newton's equations and was able to figure all this out. I think it was like in the 1800s when he figured it out.
Lagrange.
Hence
why they're called Lagrangian points.
Yep.
Yeah.
Named after him.
When I was in high school, I used to hang out at a place called the Grange. We do local band shows there. The Grange.
Well, why don't you call
Not
it?
the same.
Why don't you be
Lagrange.
Lagrange? Lagrange. That's where we are. That's where I'm at.
Good times. Good times. Yes, Jack sent me a link for a sippy cup wine glass.
That is true.
I'll be sending it to you, Mom.
Yeah, like at Christmas, Liz does send out a bunch of links. It's like, this is the shit I want. Get it. Or don't. It's up to you.
Yeah, just, Anyway. All right, cool. Lagrange Point, hanging out 930,000 miles away from the Earth. It's far away.
Yeah. But I mean, there's a reason why you want to be there. Like I said, you don't have to spend. You can go there and not spend a lot of fuel to actually stay in that orbit. Mm-hmm. So it's really nice to be there. And now, like I said, it's going to be orbiting that point, and it's going to be at its closest. I think it's something like roughly 250,000 miles, which might sound familiar, as in that is the distance. Yep, the moon distance. But at its furthest out is something like 800,000 miles. Okay. So it's this really big ellipse.
Yeah.
Around the L2.
All right. I mean, that makes me nervous.
I know,
it's like,
right?
It's so far away. It's like
it really is quite far away.
It's like when we send, any of the rovers to Mars. It's like nobody can help you, little buddy.
Yeah,
You're on your own.
I mean, we're all gonna knock on wood for this, but we've been very successful. This is not the first spacecraft to go to L2.
Yeah.
I
think it's just because there's, this is a big project. It's been over budget. It's taken a long time. I mean, it was initially planned for launch in 2007.
Yeah, right?
So, it's like, it seems like there's a lot riding on it in a sense.
Well, there is a lot riding.
And then it's like, if something goes wrong, then, general public and all those fucking ignorant bullshit Congress people, they'll just be like, oh, what a waste of money. Let's not fucking keep exploring space, So it's like, you don't want to see it fail because, there are, the people that fund this are all about money.
Yeah.
And not, well, still, this was a venture that was worth spending that money because we need to make those steps in order to advance as a society. Because it takes learning and exploring this final frontier to advance as a society and develop those new technologies that we need to pave the way to a better future.
Exactly. Well said. Well said. And you know what? I mean, let's be honest. Okay, so originally it's supposed to be $1.56 billion, whatever it was, for the Space Telescope. That is less than those stupid planes that fly over our heads.
Oh, yeah. I mean,
And ultimately, this costs the same as one of those planes.
I mean, the allocation of funds in this country, clearly.
Yeah. And every day we have at least, 5 or 6 of those planes fly overhead. So we're spending money, and we're spending a lot of money on things probably we shouldn't spend money on. Yeah. So $10 billion sounds like a lot, but it's just a drop in a bucket as far as I'm concerned.
Yeah.
We should be spending more.
Yeah.
To be honest. Are we concerned about asteroids that are also caught up at L2? I don't think necessarily.
I guess not, because I would think they would have planned for that, or
Yeah.
there's
But
they
remember,
know their orbits enough that James Webb's not gonna.
yeah. Now the thing about L2 is one of those quasi-stable orbits, which means that it's easy to stay in L2, but over time, anything that is in L2 is actually going to end up moving away. It takes a long time to do that, though.
Okay.
The only stable Lagrangian orbits are L4 and 5. And so if we were going to L4 or 5, then they'd be a little bit worried about the asteroids that are there.
Oh, okay, so the asteroids, so it's kind of like they're gonna move off.
Yeah, they're gonna end up moving off. But it's gonna be a very long time. But they're gonna end up they're going to move off. I don't know what L6 is, but
Jack's adding his own Lagrange points.
yeah, he's that's Jack's. That's the Northrop point.
I mean, I would prefer there to be 6, just so there's a nice even amount.
Even number?
Yeah.
Yeah.
But physics isn't as OCD.
Yeah. 6 was a
Typo.
Oh, okay. Yeah, 4 and 5. Oh, yeah. That's where you end up being worried about asteroids.
Okay.
Because we can look at like Jupiter, and we see the Trojan asteroids associated with that.
Yeah.
And they, like we said in the last episode, I think it was last episode. Sure. They think that there are more asteroids in Jupiter's Trojan, L4 and 5, than there are in the asteroid belt itself.
That's right, and that's crazy. That's still mind blowing because
it is mind blowing.
I mean, the asteroid belt is the asteroid belt. It's fucking.
Right, and they think, well, they don't think there's necessarily more. They think that it rivals that number.
Okay, well, still.
All right, that's funny. Jack saying, after all the Christmas goodies, I have my own gravity-causing L6.
Yeah, well.
Yes, indeed.
I made a bunch of peanut butter cookies last night.
We did. We have been eating up a storm here in the Davis and George house in the past few days. So
I'm living it up.
Yeah, we've gotten past 2020 Part 2, and now we're
now
filled
into
with
2020 Part 3.
Oh no, we still have hope
the
and
third one's always the worst sequel.
Yeah.
Usually.
Oh God, we need to move. I think we need to move to Oregon.
All right. Okay, what else we got about this telescope?
Oh, I don't know. What do you want to know?
I don't know. Okay, so we got let's talk about its instruments. Let's talk about its instruments, and then we'll go into the launch, and then like what it's doing now, and then what's next, the timeline.
All right. Well, I think when we look at the James Webb Space Telescope, there are two things that just immediately pop out.
Okay.
And
visualizing it right now.
And this actually might be, like, a correct use of literal, because it does kind of pop out.
Oh, okay.
It would be the sun shield, which is the big diamond thing.
Oh, yes, and then the honey hexagons.
The honey hexagons, the 18 honey hexagons, which we still have not found out what it is in a honey hexagon, but I'm sure we'll find out at some point. All right, so let's begin with the sun shield. The sun shield is basically it cuts the telescope in half. You have what they call the hot side and then the cold side. Mm-hmm. The hot side is the bottom of the telescope, which is what actually faces the sun.
Yeah, okay. Which gives it power, helps give it.
With the solar.
Oh, yeah, it has the solar panels. Okay.
The solar panels.
We're talking about the sun shield. Got you.
Right, and so this, since we're looking at the infrared, we need the telescope to be cold.
Because if it's hot, that's going to give off infrared, and so it's basically going to see itself like that. You know, when you're looking through binoculars or whatever, and you see your own eyeball, your eyelashes, and you're like, no.
Mm-hmm.
Okay.
Oh man, that drink's gonna mess me up. Anyway, so I don't know why I decided to do this.
I don't know, but Happy New Year.
Hope and optimism of 2022. So the sun shield what it does is it prevents the heat from the sun, the heat from the Earth.
Shields from the sun.
Exactly.
It's like sunscreen for James Webb.
Yes, and they actually gave it an SPF. It is an SPF of something like 1.5 million.
Oh, I need that because I always burn.
Yeah, so they actually calculated the SPF for it.
That's great.
That is great.
That's fun.
So
wait, let's look at the app. How hot is it right now?
All right.
On the hot side.
On the hot side.
And then the cold side.
On the hot side.
It has 2 different temperatures. We don't know what.
I know what they mean.
Oh, you know what they mean.
Yeah, I looked them up.
Oh, okay.
Okay, so you have 2 temperatures on the app, and in the center of the hot side of the telescope, it is 64 degrees. Balmy.
That's
64.
Nice. That's nice. That's what our house temperature is set at all the time.
Yeah. We have not seen 64 degrees here in Ogden
outside for a while.
Since like September.
Yeah.
October.
I'd say September.
However, in the middle of the the sun shield, whatever, is about 136 degrees. So a little toasty. It's Phoenix.
It's a little toasty. It's not bad.
It's Phoenix.
All right, the cold side.
Okay, so the cold side, just to show you how effective this is at blocking the sun now that it has unfurled. Mm-hmm. In the what is going to be the center, the average of the honey hexagons, the mirror segments.
That's what it is?
Yep.
Okay.
177 degrees below zero.
Chilly.
Cold.
Chilly.
But a little further out from that, 314 degrees below zero.
Oh.
Even colder.
Wow.
So that sun shield is very effective.
Yes.
And it has unfurled. It has actually, they have deployed it. Okay. They have unfurled it. What they need to do now is actually expand it out.
Oh, okay. Iowa is a balmy 4 degrees Fahrenheit.
Oh, whatever. Get up. No, we were 8 degrees last night, and we were like, holy shit, this is cold.
You know what? I took Leia outside last night to go potty, because girl can't hold her pee all night. But anyway, and I went outside, and I walked out to look at Orion, because the sky was pretty clear, and like Sirius was really bright and twinkly. So I went out there, and like it was so cold, but it was also like refreshing. I just took like a big inhale.
Yeah, it wakes you up really, really quick.
And I was like, and then went back inside and was like, all right.
Here's the thing: Liz and I would live on the cold side of James Webb Space Telescope.
Yes.
And not the hot side.
That way I can wear slipper socks all the time, which I'm not wearing right now because I would get too hot, but I love slipper socks.
Yeah, so. I have no socks on. Yeah. On myself.
Anyway, that was a detour.
I know, right? Anyway, it is, when it's unfurled, which it is now, it is 46 and a half feet by 69, so 47 feet by 70 feet.
All right.
Size of a tennis court is what I found out.
Oh, wow.
To give it perspective.
Okay, that helps, because I was starting to visualize our old dome being at 60 feet. But since we have a tennis court by us, out that way. It's out that way, everybody.
Yeah. Just pick a direction. It's west. It's west of our house. It is.
Wow, okay.
It's about the size of a tennis court.
All right. That's actually. I don't know if I'm conflicted if that maybe is smaller than I think. But okay. Maybe not. I mean, it's big.
Yeah, it just said tennis court,
all right.
and I always think that, but maybe like those people who do, like, they make money hitting the ball.
Professional
tennis players,
athletes.
Maybe their tennis court's a little bigger.
I don't know. I'm sure that's regulation out there. Don't they have to all make them? Anyway.
I don't know. Whatever.
All right. So that's the sun shield. Oh no.
We got
There's some more facts, which that's really cool. But I'm gonna ask you a question about it that I don't know if you know the answer, but.
Okay.
All right. Go. Say it.
What was your question?
No, say what the fact is.
Oh, okay. So it's actually made of silicon captain and aluminum captain Captain is a film
Crunch?
used in flexible printed circuits and space blankets.
Space blanket. What's a space blanket?
I don't know. It keeps you warm. I don't know.
Are those the ones that like when there's an emergency and like the firefighters always put over you?
Oh, maybe.
To keep you warm, or is that
Maybe.
just a fire blanket?
This helps. It'll help keep the mirror and the instruments below 50 degrees Kelvin, which is 370 degrees below zero. So cold.
That's cold. God, I keep getting. Speaking of the cold makes my hair ridiculously staticky. I don't know why.
Okay, each layer of these has the thickness of a human hair.
How many layers are there? That's the
There's
question.
5.
Oh, there's 5 layers?
There's 5 layers. I think there's 5 or 6 layers.
5 layers of the sun shield,
Uh-huh.
and each layer is as thick as a human hair?
Yeah. Each layer is as thin as a human hair. All this guy does is just block the heat.
Man, that's crazy.
Yeah, and the silicone layer is the first 2 layers. So the sun-facing side has a silicone in it, which will block most of the heat on the first 2 layers. But all 5 of them have aluminum in them.
The silicone... I'm about
Boob
to ask
stuff?
a stupid question. Does it melt?
No, it's not going to melt.
All right. Well, that's good for all those Baywatch actresses of the 90s.
Yeah, you don't want it to. Yeah, you don't want it to melt. But yeah, so and that drops the heat obviously from 136 degrees to 314 degrees below zero. That's a big drop.
Nice. That's a good air conditioner. All right. Cool.
What next?
We got the primary mirror.
Okay,
which
all
is
right.
the honey hexagons.
The honey hexagons.
That look beautiful.
It is beautiful.
Why hexagon?
Well, it's you can actually if you do circles. The
They don't
idea
connect well as a circle because there's no edge to it.
Right, and so with a hexagon,
you do multiple to make the
one
larger.
segment can go right into the next segment.
Okay.
But if you do segments, like this is bigger. If you take all 18 of them, it's bigger than the Hubble Space Telescope. The Hubble Space Telescope. Where did I have it? I don't even know where I have it. The diameter for James Webb is 21 feet 4 inches.
Okay.
So nice big, nice and big.
Nice big.
Nice big.
Hey. Nice big.
Nice big. 10 billion and worth it?
Nice
With
big.
champagne?
Nice big.
Nice big. And the Hubble Space Telescope
I like
for
big mirrors in a can.
God, this has just gone off the rails already. We're not even in
great
the
episode.
hangover.
It's a great episode. I'm having a good time.
The Hubble Space Telescope's only
We're having a good time.
8 feet. So much bigger. Much
Hubble's
bigger.
only 8 feet?
Yeah.
Hubble's only 8 feet?
8 feet.
So, I guess the rationale of hexagons instead of like one big, a solid mirror, one big mirror is you can fold up the hexagons.
Well, they had, this is,
Which
you
they
had
have to do it.
Yeah.
And then also there's then less room for error when you're making that bigger to get the correct.
It's true.
Oh, and is it that they can use the mirror segments and they can do micro like movements to get like fine adjustments to get like optimal focus.
Yes, exactly.
Which you can't do with one single solid mirror piece.
Right. I mean, you can, but it's a lot more complex to do.
Okay.
And they will actually employ this with ground-based telescopes. And so you have these micromotors that are going to reposition.
When they do like interferometry.
Well,
okay. Look, I wanted to use some fancy vocab words to show I know things.
Right. So, all right. So when you look at a picture of an observatory, one of the really cool pictures is when they shoot the space laser up.
Yeah, that helps
Well, the
them get
laser up.
positioning, right?
Well,
Alignment?
no.
Oh, does
No.
it help blow up their enemies?
It does, yes.
Okay. only good use of a space laser.
And so when I was at Clemson University, we had a professor who was really working on this type of stuff. And so they would, Professor Merriweather, he would go out.
I'm sorry. Can
Professor
Merriweather?
Merriweather.
Professor Merriweather?
And Professor Merriweather does look like Dursley from Harry Potter, or he did. Anyway,
Oh.
yeah.
Right.
So Professor Merriweather would go out beyond Clemson, shoot a laser up, and look at the weather with the laser. Anyway, when you see the laser go up, what they're doing is they're measuring the atmosphere. And in real time, they can actually change the shape of these of the mirrors on the telescope
to compensate for the atmosphere.
Turbulence of the atmosphere.
Oh, what? I didn't know I was going to learn so much. I don't know why I didn't know that.
It's not 100% perfect, though.
Well,
and so,
is anything. Name me one thing that's 100% perfect.
You are.
Oh, my God. No.
Anyway, so the best thing to do is get above the atmosphere, which Hubble has done.
Yes.
And so with James Webb Space Telescope, with these honey mirror segments, which it is now officially known NASA.
The honey hexagons.
Put it on your website. These are honey hexagons.
Honey hexagons.
These mirrors, we don't have to worry about the turbulence of the atmosphere, right?
Because you're way beyond it.
Yes, but we do have to worry about them being focused. And whereas ground-based telescopes have to really focus these mirrors daily, minute by minute, in a lot of cases, with James Webb Space Telescope, you don't have to do that. It's just once every few days. Just make sure the alignment's perfect.
Let's hope they can get focus.
What's that?
Let's hope they can get focus, because that was a little bit of an issue with Hubble that we can't fix if it happens with James Webb.
Hubble had a single mirror.
Oh, it had a single mirror?
It has a single mirror.
Oh, okay.
Whereas James Webb does not. And, okay, so here's the thing. James Webb is going to be deployed. It's going to be good to go in a matter of days, actually like 20 days. That's not
a matter of days. That's long. A matter of days is like 5, most.
Okay. In
multiple
3
weeks.
Of days. In 3 weeks, the James Webb Space Telescope.
And then delay. Yeah.
Oh yeah.
Anyway.
What was I talking about? All right. So in 3 weeks, it'll be at its L2. It'll be orbiting. They're going to be actually, I think, starting in the next week and a half. They're going to take a picture of a star. And it's going to be completely out of focus, folks. So don't get upset.
Don't freak out.
No.
Don't be alarmed.
Pretty sure they're not sharing this picture. But it's going to basically be about 18 different pictures of the star. Yeah. And they're going to use those 18.
Help gain focus.
So then they'll move the individual segments one at a time to focus it.
Oh, wow.
Yeah, it's going to be that what they're going to focus it to is the center picture. And it's
kind of like when you're using a telescope that tracks, and you have to align it with your guide stars, which are usually like the Polaris and something else or whatever, or at least a couple other bright stars. And then you need to get that alignment going, so the telescope knows where it's looking. Not necessarily with focusing, but you're getting that frame of reference and making those adjustments to get your settings correct.
Exactly. And then they're going to spend about 5-6 months.
How do they move these mirrors? Is it someone with a joystick that's just like... the faintest movement is just like, oh shit, too much.
It's an Xbox controller. And
they got the world's top gamers on it.
Yeah. So there's going to be There's gonna be somebody playing like Assassin's Creed with his Xbox controller and just like really boss fight, and taking on somebody from Assassin's Creed Valhalla. I can't remember; it's been so long. Maybe one of those mythical creatures you got to fight, and then the boss comes on like, shit! I got to change over to
to the telescope.
telescope. Oh yeah, I'm
Gee, how's it
completely
going?
changing.
Yep, we're moving those mirrors. Mirrors are moving.
Moving.
Mirrors are moving.
God damn it! Now I have to change my Xbox settings to make a slow move. No, I'm sure it's all computer that drives
it's
it.
Code.
But I really do like the idea of somebody using an Xbox controller or PlayStation
It's
controller.
James Webb is telescope.
Like an Atari controller, where it's just the old stick.
Yeah. Wait, no, Steve, go to your left.
Or maybe one of those like joysticks that we have in our closet from old Digitar days.
Yeah. 1998 joystick.
Oh, gotta love 10 billion and worth it.
10 billion and worth it. All right, so cool.
Yeah, and they're micromotors, and so that means they can move them incrementally, very very slowly, or not a lot.
Ooh, I have a question.
Yeah.
What kind of protections? No. Oh, well, is it? What kind of protections for space is there? Like cosmic rays and stuff. Is it still within like the bubble of the Earth's magnetic field where it's getting this shit deflected? Or,
definitely not as much as here.
Like, micrometeorites, like...
I'm going to say not so much, no. Because even here on Earth, I mean, you're seeing the effects of the sun's it's not cosmic rays, the sun's, the solar wind slamming into the atmosphere.
Yeah.
And that's just what? Tens of miles, hundreds of miles above the poles of the Earth.
Mm-hmm.
But is it
you're referring just for the aurora?
The aurora, yeah. The aurora.
That's the effects of the solar wind slamming into the Earth's atmosphere. And it is slamming.
It is slamming.
It's slamming.
Yes. But is it in that kind of teardrop, that wake?
Mm-hmm.
That's a good question. I'm not sure, but I can tell you that the magnetic field at that point though is much less than what we have like with ISS and Hubble.
Yeah, because it's
and
much
so
farther.
some of those are going to get through.
Mm-hmm.
And there have been engineers and scientists that have been working on shielding these spacecraft. I mean, obviously, we've had, like, the Mars Reconnaissance Orbiter at Mars for, 20-something years.
Yeah, it has been there for a while.
And it's still going. Still going strong.
About that. Cosmic hail? Did I say cosmic hail?
What? Did we say that?
I don't know.
Goddamn drinks.
Cosmic hail. Cosmic hail. Cosmic hail is now the new name of meteor showers.
Oh! Okay, NASA, if you're listening, which I know you are, cosmic hail.
Or not.
Are now meteors.
Cosmic showers are now meteors.
And,
cosmic hail. Cosmic hail.
And your mirror segments for James Webb is honey hexagons. Thank you, Brandon. Not here, but here in spirit.
Ah.
Brandon has, actually, he's taken his family, you guys don't need to listen.
You don't need to know these people.
Just, go set up the board game that we're going to play later.
All right. We got some other instruments, but let's get to the timeline. Well, okay, you know what? List through some of the instruments, key points about them, and then let's get into, what it's done and what the shit is. Cosmic hail, you know what? It could be a new age but 80s sounding metal band.
Oh yeah.
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 Like one of the top ones. Yeah. Like Iced Earth. That's a band name.
Is it really?
Yes. Anyway. All right. Some of his other instruments.
All right. You have NearCam, NearSpec, MIRI, FGS. What you fucking,
acronyms. God, the acronyms, NASA.
All right, NearCam, near Earth, near infrared camera.
Jesus.
Yeah, and so this is going to be looking at 0.6 to 5 micrometers. So
That means nothing to anybody.
infrared. It's infrared. Basically, it's red to infrared. Is really what it is. It has 10 4-megapixel sensors.
4 megapixels? What is this, 1994?
Well, god damn it. It was... You're close. It was designed in 1996. So the initial designs were 1996, and it was supposed to launch in 2007.
Okay.
And the thing is I think that, like Brandon said, like a long time ago when they developed these spacecrafts, it is what is today.
Yeah, what
so,
is...
1996? Yeah.
Oh, no. Okay.
But anyway, there's 10 of them. And it was developed at the University of Arizona.
Yay!
I get excited only because I used to live in Arizona. I really have no allegiance to that
school. I went
school.
to ASU, so really I should be like, boo. But I mean, they make mirrors under their football field.
Which is the coolest fucking thing
ever. Amazing.
Ever.
So U of A is way better than...
Yeah, exactly.
I don't know. ASU has L-Rock, and they do shit with Mars.
Yeah,
anyway, Arizona, surprisingly, astronomical.
Oh, it's got a lot
hotspot.
It's got
astronomy hotspot.
Lowell Observatory, which still does research, by the way.
Kids Peak.
Kid Peak, which is the big one.
I mean, it's some serious astronomy is going on down in that fucking party town.
And this has a coronagraph. If you're not familiar with what a coronagraph is,
it blocks out the sun, right?
It blocks out the sun, yes. Which is, why would you want to do that? Well, if you're looking...
The sun's bright.
The sun is bright, but you're not going to be looking at the sun. However, you are going to be looking at stars that maybe have a planet going around it.
Yeah, and they could be
and if
close
you
to the
block
sun.
out that star, you can possibly see the planet.
Got you.
All right.
Near spec.
Near spec, which is basically the spectrometer. This is how we're going to, quote unquote, sniff the atmospheres of planets.
Ooh, that's fun.
Yeah, so you're going to use that spectrometer.
Smells like cows.
Which is what we want,
we
people.
We want a cow smell. We want a strong cow smell.
Yeah, and so this was actually developed by the European Space Agency, and it actually has a complex series of microshutters, which allows it to get to do spectroscopy.
Spectroscopy?
Yeah, that one. It can look at the spectrum of multiple objects within its field of view. So it can look at like this star, get the spectrum, this exoplanet maybe, get the spectrum.
I'm so excited.
I know,
I'm so
right?
excited for it to start working scientifically.
I know, right? This is why I am so excited, and why it was just an amazing thing to watch this thing launch. I mean, for one thing, you're watching a launch, and that is always just beautiful to look at.
Yeah.
But it is the hope and optimism that this is bringing to us, that we are going to have a much better understanding of the universe that we live in.
This is meaningful, not like a bunch of fucking billionaires getting their rocks off.
Yeah, exactly. And I have always felt that, humanity has to advance, and we don't advance through billionaires launching themselves up into space. Just
in our overly compensated rockets.
Yeah, that. Oh God. Hey, we just launched a big dick up into space. Yeah, Bezos, way to go.
He ain't patriarchy.
It's not where we truly advance is not these military things that fly over our house and
the
blow
domination of other countries and people.
Where we truly advance is art and our knowledge of the universe.
Science.
Art and science, yeah, and so. That's why I'm so excited about this telescope, is because it's going to let us know that it's going to let us understand the early days of the universe that we live in, and what was that like, and we're going to make discoveries about galaxies and things like that, but also hopefully we can find life somewhere else and we're not alone. And you know what? To be honest, I realize
Not alone. Okay.
I realize that there's like when you're trying to find life, there really is two questions. Is
there
it
anybody out there?
is there anybody out there? But also, is there anybody out there like us? That is
Well,
that is
probably not.
advanced. And
Advanced, yes. Like us, no. We
Right
will
now-
be very confused.
right now, I just don't care. Just
I'm very
let's
excited.
find life. I think that if you find life, if it is just a little bacterium somewhere,
Yeah.
then that means that we're not alone, because this Earth, the planet we live on, is predominantly
Bacteria.
bacteria,
Wear
and
your fucking masks.
the COVID-19 virus, apparently. And so there's going to be a planet though out
yeah.
there.
Also, never mind.
Well, there's going to be a planet out there somewhere where that bacteria, maybe it evolves into algae, let's say, which then evolves into eventually down the line a fish, which then can then walk out onto some land, which eventually becomes dinosaurs that get wiped out by an asteroid,
Oh, no.
and then mammals.
What if you get smart dinosaurs? What if you have some real clever girls?
There's a whole show from the 90s that was on
Dinosaurs,
dinosaurs,
yeah.
smart
I
dinosaurs.
mean, you know,
What was the name of that show?
dinosaurs.
Oh, was it? Yeah, dinosaurs. I just Jim Henson,
Dinosaurs.
dinosaurs.
It was great. I remember that. All right. We got you know,
Mary?
it's got some other instruments. Let's get timeline it. Let's go timeline.
All right. Well, you're in charge. All right. So, I mean, everything that has happened
Has happened.
has happened, and has happened successfully so far.
All right. So it launched.
Mm-hmm.
Uh,
They deployed. One of the first things they did was deploy the solar arrays.
yes. So
And-
they were like,
Me, you, and Brandon were sending texts back and forth about that.
Yes.
And so, but then they do a couple of mid-course corrections that are in there, and all that. But the big thing was that we were going to be worried about was the deployment of the sun shield. It was folded up 12 times just to fit in this rocket.
that's a lot of folding. That's
Dinotopia.
That's one of, I remember Dinotopia, I think. That was one of, that's one of those things where, like, once you fold it, like, you're not getting it back. Like, old maps.
Which we talked about at Christmas, by the way, with your dad, because he was talking about getting the maps to go everywhere. But anyway, yeah, and so that was the first. You need that sun shield.
Yeah, because if you don't, things are going to get too hot, and then they're not going to work, and then you just got a lot of money floating out in space doing nothing but freezing.
You got 9 billion just floating out in
Just
space.
hanging out. Just, all right.
And to me, it's still worth it. Love that telescope. But anyway, so all right, so it deployed. So what they want to do now though is they actually right now it's just flat. They need to.
Oh, they need a.
The tensioning part,
it
which
has
is
to-
actually have it
to
drop
make it-
down. So it's actually out like the size of a tennis court.
Isn't it supposed to be like?
But no, but it's already the shape that you're trying to do.
Oh, okay.
This diamond shape. What they need to do now is actually drop it down. So remember, there's 5 layers. Right now, it's just like 1 layer.
Oh, okay. So they have to spread it out.
Yeah, they have to spread it. That's the word.
Spread it
out.
Okay.
Of course, NASA doesn't say
They don't want to
spreading it
drop
out.
it like it's hot.
They call it tensioning.
Tensioning.
Yeah.
Yeah, because there's a lot of tension. This is a stressful maneuver.
Yes, there really is, and that's the next thing that they were going to do. They were going to do it starting yesterday, but the unfurling of it to the size of a tennis court, it took a little bit longer than they wanted it to do, and so
Hey,
they're
slow
like
and steady wins the race.
exactly. They're like we have a little bit of time built in. We're gonna say.
I mean, how many plan Bs do they have?
They actually have one plan B, everything is redundant
Yeah.
on the telescope. But so what they told everybody was, hey, let's take a break. Let's everybody get some rest. It's been
relax, chill out.
literally that's what they told them. And then the plan was for them to come in today and start separating it out. But they decided, why don't we just see how it is adjusting to being in space and how things are.
Oh, they're thinking about its feelings.
Yeah.
You got to make sure you're getting well adjusted. Get
Yeah.
that feedback. Like, how are you doing? Are you okay?
Mm-hmm.
Do you need anything?
Pretty much, exactly. And so they're actually going to start that separation tomorrow, and it's a 2-day process. And so
they're gonna start it on a Monday.
I know, right? So that all starts on January 3rd, so tomorrow, yeah, and then they will start doing the really cool thing where they kind of bring the mirrors out.
Oh, are the mirrors like folded in right now?
They're folded in right now.
All right, so they got it's like a flower.
It is like a flower.
They got a bloom.
Yeah, and that starts on the 8th. So in about 5 days.
That's what Jack has his vet appointment. His comprehensive exam on the 8th.
Okay, so my first thought was, because we're in the podcast, I'm like, why is
Jack?
Why is Jack going to the vet?
Well, he does have a lot of cats, but I don't want him to have to take his cat to the vet unless it's just a routine checkup.
So
which is what Jack will be doing. All right.
They'll deploy one side, and then the next day they'll
like
deploy
this,
the next side.
Boop, boop.
Yep.
Hello.
Hello,
world.
And on the 10th, on the 11th or so, it is on the 10th. I'm sorry, on the 9th. On the 9th, it will be deployed.
It's just deployed.
Yeah.
It's fully deployed.
Fully deployed, and then what they do?
It's out there.
It's out there. They'll hang out for a couple of days, and
be
by
like,
they
are you checking in, just like, hey, you're fully deployed. How you feeling?
How you feeling?
You're out and proud.
We're gonna take a rest.
We're gonna go take a nap.
Yeah.
Get some coffee.
We're gonna have a 10 billion and worth it, and we'll come back.
We're going to take our Christmas break now.
Yeah. And then they'll start fine-tuning those mirrors.
Okay. So when do we get some actual science happening?
In about 5-6 months.
And is it like Hubble where people have reserved time to use it, or is there a starter kind of thing that they're going to be looking at with it?
Oh, well, okay. There's a lot of questions in there.
I think there were 2, but it's a lot.
Okay. What they need to do is they need to have the telescope cool down.
Yeah, I mean, once it's ready to go. Once it's like,
so that'll be,
alright, I can explore.
It'll be in about 5 to 6 months.
Okay, yes.
Okay. And so in 5 to 6 months, this is a research telescope like Hubble.
Okay.
And scientists do have to reserve time.
Okay, so it is not like you have NASA that's like, we're going to start off here. And then it's like the time for the scientist comes in,
But having said that, NASA is going to take that first picture.
Oh, okay. Well, but not the blurry test picture of the alignment. It's like... do they have a target of what that first like picture, like that mind-blowing, beautifully artistic, scientific space photo is going to be?
You know what? To be honest, I think that if everything works out the way that it should, and hopefully will, they should take a picture that Hubble has taken. Because then you can do...
Oh, yeah. Compare. You can compare and you can kind of see.
So then you bring up...
And it's also an homage.
Yeah, let's say...
What was Hubble's first picture?
Oh, God, the blurry one. Was it M101? 110?
They should, yeah,
whatever
they do.
It was?
Oh, my God. If they do M101, then that'll be like... It's almost like a full circle into then the new.
Yeah. And NASA, I know you're listening. This is what I am thinking. At the press conference.
He's fancy physics man, so you should listen to him.
Or hire me. I don't care. Start off with a ground-based picture. Of 101, 110, whatever it was. And then show Hubble. And then show the James Webb Space Telescope. Just have it crossfade from one to the other, and then point shit out, individual star, cloud of gas, whatever, or take a picture of like an exoplanet. But I think becomes powerful is
it's like with Pluto. Like, how you have Lowell, and then you eventually have Hubble, and then you have New Horizons, and that evolution of imagery and then the science that goes with it is like,
it shows the advance.
It shows that advancement while paying homage to it's just like, hey, here's
like,
how we see things now.
I know I've said this many times, but we all stand on the shoulders of giants. And that is not me. That is Newton. Isaac Newton said that. When asked why he could see so far, he said, because I stand on the shoulders of giants. Kepler, Galileo. And so I think with James Webb Space Telescope,
it orbits on the shoulders of giants.
It does. James Webb, what we have learned from Hubble, from ground-based telescopes and all of that, is going into the James Webb Space Telescope. James Webb Space Telescope is not by itself. James, don't look over my shoulder like that.
I'm sorry.
What, is there a fucking...
No,
is there
continue.
A ghost?
I was planning my next thing, so I'm sorry. You continue.
The James Webb Space Telescope is the continuation of...
sorry, it
of
was
everything
the ghost
that we've...
of Hubble.
Don't say that. Hubble's still going, right? Is everything that we've learned. It is James Webb is the child of Hubble, which is the child.
I meant the Edwin.
Yes, of the Keck observatories of all of this, and so it's not isolated.
No,
none of us are isolated. By the way, we're not
all connected.
To quote Dolly Parton and Kenny Rogers, we are not islands in the stream.
Wow, that was a reference I did not see coming at all.
Yes, and so we are all connected. We are all a thread in the tapestry.
A thread in the wheel of time. It's for you, Brandon.
Which was disappointing because we were going to get, we got a wheel of time last night, and they're like, oh no, we don't.
Jack says he read one of the first targets was going to be TRAPPIST-1, which then I was looking around on our travel, and it's not in camera, but it's up above this one. It's above this one for TRAPPIST-1. Yeah.
Why don't you take it off and show them? All right, so
put it back up.
All right, so TRAPPIST-1 is an exoplanet solar system, as Jack has said in chat. However, it's not just... And now we're going to be completely out of focus. Oh, the really cool thing is actually everything reflecting.
No, look, oh gosh. Look at that.
Anyway, we'll send you the picture. Anyway, so it's an exoplanet system, and when it was first announced, it was... hey, we did not find one planet in this solar system. We did not find two.
Oh, wait. How many did we find, Fancy Businessman?
Seven fucking planets.
7 planets in the solar system. 7.
Yes, and there are a few of these planets that are in what's called the habitable zone, the Goldilocks zone, which is where...
That's where we live.
Yes, it is. It is where you theoretically could have water.
Liquid water, which as the only data point of life in the universe, you need it.
Yes.
You need it 100%.
And so when we look at life, the only place, like you said, the only data point is here. Mm-hmm. And so everything needs water. And so that is why...
Water everywhere. But
in all the borders to drink, water everywhere, nor any drop to drink. The greatest 4 lines in a poem ever. It is... It's actually 8 lines. What? Oh God, what is it? Anyway, maybe in the Hangover.
Maybe the Hangover. All right, let's. All right, so we have basically we have a wait, people. We got like 6 months. We got summertime, the summer of Webb,
The Summer of Webb.
with no serial killings. Summer of Webb.
What?
I was thinking Summer of Sam.
Oh, okay. God, that was...
Did your mind not immediately go there?
No.
No? Anybody else immediately think serial killer? Okay.
So maybe
Summer
we
of
dedicate
Webb.
all of summer of 2022
Summer
to...
of Webb. 2022 is the Summer of Webb. So, and I'm sure then, once Webb starts its science, we will have another James Webb recap and update.
Oh, yeah.
Pointing out the amazing science that starts to come from it. Of course. Okay. Well, you know what, Mom, it's your fault. You let me watch horror movies from too young, but I'm not complaining.
Okay.
Anyway.
You're in charge.
Okay, we're gonna go to The Hangover.
Okay.
I think we've talked a lot about James Webb, and it's true. Only I would think of serial killer.
But you know, we watch a lot of murder on Netflix.
We do, but I've been watching it for all my life.
True.
So, in a couple weeks, everybody, James Webb will reach full deployment, and by summertime, in roughly 6 months, it'll actually start to be used for science and exploration, and I think that all our minds will be fucking blown.
Yes.
And I'm looking forward to it.
If there's
one piece
blown.
of light and hope for 2022, it's James Webb. So, again, I'm out of alcohol, but cheers.
Are you? Cheers.
Well,
you have a whole thing over there
in front of me. Cheers again to the James Webb Space Telescope and the scientific frontiers of humanity. And let's hope that it makes us all better people in 2022 who learn how to wear fucking face masks. It doesn't hurt. You can breathe. You're fine.
Yes, Mom. Cheers.
Cheers. Thank you guys for joining us. Follow us on all the things at Drinking Cosmos on Twitter, Cosmos with Cosmos on everything else. YouTube, Anchor.fm, Spotify, all your favorite podcast listening platforms. We will see you in a couple weeks with some topic to be determined. I have a feeling it'll be in some way related to space. And drinks will be had, and all will be merry. But for now, if you're sticking around with us, we'll see you on The Hangover with Cosmos. But for now, be safe, and Happy New Year, everyone.
Cheers, everybody. Happy New Year.
We'll see ya. Cool. All right, for those of you on YouTube, we'll be right back. While I figure out
how to make a mouse work.
I don't need my mouse for this too either. I got a new mouse and keyboard that I got with my Best Buy gift card and some other gift card that I won from work. So it takes a bit. Anyway, we'll be right back in The Hangover.
We'll see you.
Hang tight. Welcome
Hey,
back
everybody.
to the Hangover with Cosmos. With Cosmos.
Exactly. But we're going to start with a little poetry.
Oh.
Day after day. Day after day. Oh, God, I fucked it up already.
Wait. I was...
Day after day, day after day, no breath, no motion, as idle as a painted ship upon a painted ocean. Water, water everywhere, and all the boards did shrink. Water, water everywhere,
But not
nor
a-
any drop to drink. The
Yay!
the most despair in 8 lines of poetry.
Ship life was rough.
It was complete. He shouldn't have shot in that albatross. That's all I got. Rhyme with Ancient Mariner, in case
Never
you're
shoot an
wondering.
albatross.
Never shoot an albatross with an arrow. But anyway, and so or a gun or anything.
I was going to say, only with an arrow? Okay.
But guns work, yes. Because freedom. But anyway, Rhyme with Ancient Mariner, favorite poem ever.
Wow.
Yep.
Well, there's not a lot of water to drink in space.
and if you don't want to read the poem, listen to Iron Maiden's adaptation of it.
Oh yeah, yeah. Listen to the Maiden.
Yeah.
That's fun. Okay, so in the main episode, we were doing a James Webb Space Telescope recap of what's been going on with JWST. Everything's good.
We're on first
Everything's
name basis
fine.
here.
JWST's cool. He's cool and he's hot, but he's more cool.
But he's also cold.
He's cool where he needs to be cool.
But hot where he needs to be hot.
And things are on schedule and looking great.
So far, yeah.
And in 6 months, it's gonna do some shit. Roughly. 6 months.
Yeah, it's going to do a lot of shit,
It's gonna
hopefully.
do some shit. So that's the recap from the first episode.
Yeah, so no need to listen to that first hour and
That's
5
everything
minutes.
that happens. Hi, Mom.
I love that your mom says hi when she's already been on like the whole time.
what do you want to talk about in The Hangover?
Our bullet point says, "Who knows what we will talk about."
That is always a question.
I've already done my poetry reading.
You did do your poetry reading. It was beautiful.
Yeah. Well, okay. All right. One of the things that I would like for discovery of James Webb.
Okay. So these are your hopes for the future.
Yes.
Like Fancy Physics Man's 2022 hopes for the future.
But to quote Pennywise, living just for today, I haven't put a lot of thought into this.
Okay.
And so one of the things that I am looking forward to is James Webb being able to, are you, where are we going? Okay, it's just me now. Liz is left. And
I was going to open the gate so Winter could get in.
James Webb Space Telescope, using its ability to look at the spectrum of planets and so forth, being able to sniff the atmosphere.
Sniff the atmosphere, so to speak.
Yeah, and so
that is exciting and amazing.
Yeah, because right now we look at these worlds, these exoplanets that we've discovered. We know some of them have atmospheres because of the way that the light from the star passes through what little bit of atmosphere we can see.
And you get like the absorption spectrum.
Right, and so, but James Webb is going to be able to take it to the next level. And so we're able to...
That's how we do next level.
Yeah, and so one of the things I'm really interested in is how much methane is in the universe.
Yes, because methane equals farts.
It does equal farts, but it also means that there is...
there could be a biological component to
biological
that
component. There also can be a geological component. The thing is with... Leia's just devouring a cat.
She likes to chew on Winter's whiskers. Winter allows it.
And Winter is so nice. But anyway...
He can come in.
Okay. Oh, good. Puppy farts. The thing is methane is not stable in atmospheres. Ultraviolet light breaks it apart really easily.
Okay.
And this is one of the things that's really exciting about Mars. Mars has this methane anomaly that shows up every year at the same time, kind of in the same place.
He's just got like seasonal IBS.
Yeah. And so if methane is broken down quickly, and you see an atmosphere that has methane in it, what's creating that methane?
Oh yeah, something is fueling it. Something's is producing that methane, because methane isn't just, you have to have things come together to make methane.
You do have to have things come together.
It's a compound.
It's a molecule, yeah.
I don't know.
Anyway, so if you have an atmosphere that is rich in methane, there's a chance that it's much cows on the surface of that planet.
Space cows. Space cows just farting away.
Just, hey, you know what? Yeah.
Yeah.
That's what they do.
I mean,
they're living their best life until
that
one day.
Until that
one day in which they are not.
They get hit in the head.
And then, yeah.
And then a bunch of vegans get mad, but our tummies get full because they taste delicious.
Those steaks taste so good.
Ooh. Anyway.
And in fact, when we leave the podcast today, we're gonna go have some cows and chickens.
Yeah, actually. All our leftovers from the past couple of days will be consumed. It's a real farm up in our bellies.
We're limiting the money that we spend.
Okay, Katie asks, what...
It was.
What... I read the first part before I read the second part. What...
Actually, well, what something like
Bang,
a cow.
What if the Big Bang was actually just a big fart? I mean, it's a big sudden
fart,
just expansion of space and time. I mean, that's kind of what it feels like when you fart a little bit. Like you've just expanded space and time.
I'm sorry. Just...
Did I break you? I broke him. I broke him. I finally did it.
Yeah, every time you fart, it's a cosmic. It's a Big Bang. It just made a universe.
I mean, it's like an expansion of nothing.
Of
something from nothing. But a lot of buildup. A lot of beans.
All right. There is a question of how them drinks treating you. They're doing okay.
Fantastically.
They're doing okay.
Fantastically. Honey hexagon.
The big fart apparently was a joke in the Family Guy. According to...
what farted to make the Big Bang?
A cow.
Do you need something to fart? Could a fart just happen?
Oh, you know what? For the Vikings, it was a big fucking cow. It was a cow.
Well, of course. That was their main...
It was a cow, so it was the Viking cow that actually farted.
It's cows all the way down.
The universe. It's
cows all the way down.
No, chickens. I realize.
I'm supplementing.
I know, but Ron might be listening. It's chickens all the way down. Chickens all the way down.
God, the cosmic frat party with other deities playing with a match. Classic.
All right, so if you don't understand the chickens all the way down reference, it actually is turtles all the way down. That's the official reference.
Yeah. And then we have an inside joke. You don't need to explain the inside joke.
Okay. Well, no, I'm not going to explain the inside joke. Okay. I'm going to actually would explain where the turtles came from.
Oh, yeah, the turtles.
All right. So there was a lecture. I can't remember who it was. It's early 1900s, and I have his book on my bookshelf, but I just can't remember his drinks.
We have his book?
Yeah, Bertrand Russell. Bertrand Russell was giving a lecture in, I believe, England.
Naturally.
Yeah,
with
naturally.
Professor
Bertrand,
Merriweather.
yes. And so he was talking about the universe, really. And this lady came up to him after his lecture and said, "No, you're all wrong. You're all wrong. I just live in a house down there. I paint pictures of castles.
Oh,
That's all I
wow.
do. But anyway, I know everything about the universe there is to know."
Oh, no.
She said that it was 4 turtles holding up the universe. And Bertrand Russell just asked the question.
We were just set back another 200 years as women right there.
Yeah. He asked the question, which, any of us would ask, what are the turtles standing on? And the lady said, it's turtles all the way down.
It's
just it's all the way down.
All the way down.
And we have a friend who really likes chicken, so now it's chickens all the way down.
All the way down. How long is all the way down?
All the way.
It's infinite.
It's just all the way.
Infinite turtles and chickens and cows.
Yes, farting.
Making
big bangs.
Hey, the multiverse is just a bunch of fucking farts.
Yep.
It's just a bunch of farts in the ether. And gas giants were created. Exactly.
I love how they last for Chaz or your mom. Fiverr. Kaboom. Toots. Gas giants.
I was trying to fit in like a Uranus joke in there, but anyway. All right. That's fun.
Yeah, that's when you call it Uranus, though.
Yeah.
That's the appropriate time to call it Uranus.
Yes. Even though the proper pronunciation is
Uranus.
Well, no, it's actually for Greek, Uranus.
Oh.
Uranus, which sounds way more classy.
It does.
Than Uranus, bro. Uranus.
Yeah, but Uranus is such a frat boy thing.
Just like Uranus.
Yeah. She said Uranus.
All right. Anyway, 5 minutes of fart jokes discussing James Webb sniffing atmospheres.
You're in charge.
On other planets, and
I'm just here.
The presence of methane, meaning there could be possible life.
Yeah, me and Smeeks, we're just here.
You and Smeeks. But okay, the exciting thing though is, I mean, we have to look for methane and oxygen, and
ozone is also Ozone's not really
biological. What relates to us, but there's also the possibility that there could not be carbon-based life only in the galaxy, i.e. universe.
Silicon.
But there could be silicon. There could be different life we can't even fathom becoming life. But all of the elements that we've named, that we've discovered and named as whatever we've named them in our own, dichotomy. I don't know, I'm saying words at this point. But those elements, they exist the same across the universe. Our potassium is still a potassium in different name to maybe some other intelligent, species.
Right.
Our hydrogen, our helium, they all work the same way here as they do elsewhere in the universe. So therefore, carbon could form with other materials, structures of intelligent capabilities elsewhere. That was a long way of saying, yeah, obviously there's other life out there.
Well, yeah, I mean, it's got to be. To quote Ellie from Contact is awful waste of space. Actually, it's her dad.
Yeah,
that makes the quote.
The universe is so unimaginably huge. It's big in a way that we can we can't possibly understand. We can take in a number or whatever, but it's meaningless. It's unfathomable.
Mm-hmm. You actually bring up a really good point in that long monologue.
I did it. I like monologues.
Right, and 100 years ago, the question of, is physics the same here as it is across the universe?
Now, you said 100 years ago. That means the 1921. Do you mean 100 years ago or more?
Like 100, 110 years
Okay.
ago. Basically, to the point where Einstein had to say, the laws of physics here are the same as the laws of physics everywhere. He made that assumption,
Yeah.
which meant that it wasn't a done deal in the minds of physicists. But it
Well,
turns
you
out
know, when you assume, you make an ass
out of you and me. Yep. Craziest thing is when I worked a job and the boss actually said that one time. I was like, oh, shit. Well, this is the 1990s. I guess you could say that. But anyway, so that is just the assumption that physics here is the same as there is relatively a new thing in our understanding of the universe.
I don't know why not, though, because, I mean, the universe itself is homogeneous.
Right, but
so
but you can't assume that, and so at least if you're a scientist, you can't assume that. And it wasn't until the 1920s, the 1930s, that we're looking out into the universe, and we are seeing that the universe is homogeneous, that the universe is the same everywhere we look. And the laws of physics dictate the same thing here as they do across the universe. All the way across the universe. That's a relatively new thing.
Which is crazy. I mean, if we look at all of human history, I mean, we were just watching like a documentary on some like new discoveries in Egypt with the pharaohs and burial grounds and stuff, and that's like from 5,000 years ago.
Right.
And just this leap in just less than 100 years of exploration and thinking, which then makes me wonder and marvel about 500 years from now.
I know, right?
Natural disasters like climate change and our own stupidity with COVID and whatever aside, and whatever, assuming,
we survive this, yeah.
Assuming it's like, yeah. Like this, we've had such a leap in technology in such a short period of time, respectively to human history, that it's just like, how are our understanding is going to be expanded in that just a mere, maybe even a mere 200 years or 300,
I'm not even give you that long. I'm going to say 20 years.
Yeah.
What is it that James Webb is going to show us about the universe that is going to change the way that we see the universe? And I'm going to use the Hubble Space Telescope as an example.
Little HST.
Yep. And so the Hubble Space Telescope goes up and
comes down. No, it doesn't.
No.
It doesn't come
God,
down.
no. The Hubble Space Telescope has completely, fundamentally changed our view of the universe. With the Hubble Space Telescope, we have discovered dark energy, which was not known of on January 1st, 1999.
That's weird.
But by the end of the year,
I was
it
alive.
was. You were. And hopefully everybody listening to the podcast.
I mean,
was alive
but
as
to
well.
not have something like dark energy known of and discovered during your, like, when you were alive, even if you weren't, like, conscious of it because you were just an asshole young child going on teenager.
But
it's amazing.
I know, right? But that has fundamentally changed our view of the universe and everything in it. Now we have the James Webb Space Telescope, which is 100 times more powerful than the Hubble Space Telescope. What discoveries are we going to find? I mean, and they discovered dark energy within the first decade of the Hubble Space Telescope being up. And what are we going to find? We don't know what we don't know. It's going to be an amazing ride.
I feel like every generation is kind of like, this is the most exciting time of discovery, and I'm glad to be alive, But it's like, yes, because we keep advancing and getting better, so every generation is
You're right.
the most exciting time of discovery until the next, basically, So, I mean, this is really exciting, but then it's like, oh, the next generation is going to have it even better unless we revert to medieval times because of our own ignorance and dumbacity.
Is a strong possibility.
Yes.
Your mom brings up this very great philosophical question.
Oh, no, Mom, don't. You can't ask questions like that because my brain starts melting.
All right, but the question is, but you're looking at our universe. What about outside our universe?
We can't yet.
James Webb is not going to show us outside the universe. All we can do is infer.
What's the range of James Webb as far as like say can it find planets in another galaxy?
Ooh.
Or let's say Andromeda, because Andromeda is the closest. It's the largest closest. I guess the large Magellanic.
I don't think so. I think we're far out from that. But
it can detect, galaxies that are basically the first galaxies to ever have formed.
Yeah, I don't know if it can actually look at a star in Andromeda and use the coronagraph and go, hey, there's an exoplanet right there.
Okay.
Having said that, there are telescopes that have. There's a telescope that actually has a exoplanet candidate that we cannot confirm.
Oh,
in another galaxy. Yeah. And it'd be the first one. No, it's not Andromeda. It's actually further out.
It's further out than Andromeda?
Now, it didn't actually visually take a picture of it or anything like that, and it's inferred with what was
the light?
Yeah, maybe it was the light curve that did it, but the transit method. The James Webb Space Telescope could see a bumblebee flying around at a distance of 250,000 miles away. It can detect that bumblebee on the surface of the moon if the bumblebee was there, which is not, but it can see it. But you're talking about
moonbees.
You're talking about millions of light years away.
Yeah.
And so it becomes a little bit more problematic at that point.
I guess I don't really think about like how spread apart galaxies are, because then you're getting the distances are.
It's mind-boggling.
I mean, we're just in like the.
Say it.
I want to say it, but I don't want to say it because I oversay it.
Say it. Please say it.
The horse and buggy days of space exploration within our own galaxy, and even kind of within our local group, if that, our solar system and we're so primitive, yet we feel like we're right this close to the Jetsons. Like we're almost at flying cars.
She was doing the 1 inch.
This is only on YouTube. It's The Hangover.
Oh yeah. All right, but get back to your mom's question. Everything that we're seeing with telescopes and stuff like that
is in our own galaxy.
It's in our own universe.
It's in our own universe. I mean, obviously other galaxies we see.
Now there is some really exciting stuff when looking at the cosmic background radiation. Mm-hmm. There's some a little bit of a warmer spots.
There's a slight temperature.
Yeah, it was either warmer or colder region, and that implied two brains,
like galaxies bumping,
universes, universes colliding into each other, and creating that spot,
which is
but that's interpreting the data that you're seeing from the cosmic background radiation.
Here, basically, if we're talking about another universe, that is something that has formed under either the same or entirely different circumstances than our universe. So we cannot
which gets to your mom's question.
Yes, which we cannot say that the laws of physics would work in another universe the same way they work here, because our universe, and we don't know we don't know if there are other universes, but assuming if there were other universes, they could be formed by a big bang, maybe by a big crunch, they could be formed different ways, but then you could have the fundamental forces of nature not not split the same way. You know,
Right.
you maybe don't have gravity come off and with the strong and weak nuclear forces and whatever else. You know,
Right.
maybe you have, you know, a couple of them stick together and something else come off. You know, so
Right.
so physics could be completely 100% different and opposite than it is here.
And you know what? Most likely it is. And
Yeah.
there's going to be universes out there. If there are multi universes, there are going to be universes where gravity is slightly stronger.
It's
or
not going to be recognizable to our
Right,
universe in
and
any
so-
way, shape, or form.
And so, if let's say gravity is much stronger than it is in this universe, then
Start that diet plan.
what?
Start that diet plan.
Yeah, I know, right? Basically, you're not going to have stars that are formed. They will form, but it'll be briefly, and then just going to become black holes. I mean, gravity's going to overwhelm everything, and it's going to collapse down into neutron stars, eventually black holes.
There could
and
be
so
like universes of absolutely nothing right now.
Well, there are. If there are multi-universes, then there are. Let's say that the strong force is much weaker than what it is here in our universe. Maybe so much so that that carbon cannot form.
What is just for listeners, viewers, what does the strong force do?
The strong force actually is what binds quarks together.
So matter, basically.
Well, yeah, the nucleus. And so it is the strongest force in the universe. However, it
binds the smallest.
But it binds the smallest. But it only works on a very short range, and so it basically limits the size
it's
of
like
atoms.
the 2.4 gig wireless versus the 5 gig. The
Right.
2.4 has a longer range, but like the 5, when you're near it, has the
Right.
more robust connection.
Exactly, but it limits the size of nuclei of atoms, and so you get to a point where
If it's weaker, you can't have as big of things.
right, and
made.
so like yeah, if it's weaker, then you cannot have as many elements on the periodic table
You
in
can't have
that universe.
dinosaurs.
And if it's small enough to where you can't get carbon, if it's weak enough to where you can't get carbon, then you can't get life as we know it. Because we're carbon based. I got a bunch of carbon in me. Liz has a bunch of carbon in her.
Oh, I do.
And calcium. We got a lot of calcium as well. But
Iron.
and carbon comes before oxygen. And so if you can't have carbon, you can't have oxygen.
And then we can't breathe.
Yeah, pretty much. And so there are definitely, probably, most universes where you can't have life as we know it.
I feel like life is probably robust throughout the universe. I mean, the size of the universe is incomprehensible. So when I say robust, I mean like I don't even know what that means. But I feel like life in our universe is probably robust.
Mm-hmm.
But
overall, I think,
but distance, size, and how time works, it allows maybe very few rare opportunities for life to come together, where it's like you have different species from opposite ends of a galaxy meet, or even intergalactic kind of meetings, that kind of thing. But I forgot where I was going with that. I was on a roll.
I think I get what you're saying though. Like life is robust in that it's going to in the universe, in that you're going to find life in the universe.
If a universe has the capacity, the qualities to be able to form life at all in its barest, then that is going to be robust throughout that universe, because those aspects are not going to be limited to that one single inconsequential point in that huge ass fucking universe.
Right. I think overall in the universe, life is robust, but locally it's very fragile.
Well, that's what I'm saying. It's so spread out. Everything's so spread out that that two species from a different origin point in a single galaxy or even intergalactic is going to be an incredibly rare...
Beastie Boys just popped in my head.
an incredibly rare thing to happen that the majority of life in said universe won't even they won't meet another life, and it would be rare for them to even discover the presence of other life forms very far away. But what I'm then also saying is that the universe that has the capacity to form life in itself is going to be rare among the multiverse that's out there. So
no, completely.
Even though like our existence here and being able to have the intellectual evolution to fucking make lights and stream our consciousness throughout pixels over imaginary things, things we can't see, invisible things, like that is lucky and rare, but then at the same time so special in like the whole cosmos of cosmos,
right?
You know, that we get to be here, and that we have the awareness to interact and feel things and be aware of our presence, and then also to then expand and explore and see what else we can find. So even if we never find any evidence of other life out there, which I'm 100% will say statistically has to be out there in this universe.
Yeah, I'm going to say in our lifetime we're going to discover it.
Even if we don't, I can feel like, hey, even though when I die, nothing happens because I just stop. I just stop. I don't go anywhere. Like, I got to exist, and I got to be a miraculous, in essence, part of that universe.
Right.
You know? Even though there's nothing miraculous at all about it. It's just time and fucking random nature of physics that comes together.
Yeah.
You know? But I think that's cool. And that
it's really cool.
And that's great.
You know, I completely agree with you. And
that was a lot.
You know, the thing is that what's really cool about us as a species, even though we're actively trying to kill ourselves.
We're horrible to each other and every other species.
Okay, one of the endearing aspects of us. All right, so we're able to create things like the James Webb Space Telescope.
Yes.
I keep trying to bring it back.
Pictures on cave walls.
Even though, because you said this at some point, that
my ramblings.
It wasn't rambling. It wasn't rambling at all. There was like
ramblings of Liz.
There was a lot of great stuff in it.
Okay.
We might not. You mentioned that we might not be able to, paraphrasing here, meet other life in the universe. Really, unless it's on Mars or something like that. Europa.
On Mars, it would be
but the James Webb Space Telescope is going to allow us to look out and connect us, hopefully, to some life on another planet. Yeah. Just by looking at that planet and going, "Hey,
all right,
they're farts."
Even if like we're seeing dinosaurs on said planet, but then there are actually like Vulcans. You know, we don't know at that point.
Yeah, we don't know if they're Vulcans or dinosaurs.
Like, hey, all right, cool.
And so we become a member of this, larger community. Universal community. And I swear to God, I know I've said this, is I really hope for that because I really want the Star Trek universe.
I know. I want no money and replicators. I can just be like, hey, tuna melt, and I get a tuna melt.
Didn't we actually talk about that last night or something when we were watching Discovery?
We did, yeah.
Yeah.
It wasn't when we were watching Discovery. It was something else, but.
Oh, it had to have been Discovery though, wasn't it?
No, I don't think it was Discovery. It was something else because it was like. I don't know. Anyway.
All right, so your mom asked an interesting question. Unless they are shrinking, which is I
don't want to think about what we're expanding into. I can't think about what's outside the universe because then
but
it's
that's not her question.
Expand
or basically, I'm gonna add an R that was not there. Are other universes expanding into us? And the answer is no. Our universe is self-contained. Other universes are self-contained.
How do we know?
I think it's pretty. What evidence do you have?
what's in between the walls.
Ultima Thule. Anyway, you might have these multiverses, these brains, as string theory would say. Oh my God, I can't take you anywhere. That would just bump into each other and that type of thing.
This long.
Oh, first 13 minutes, you're like pouring champagne all over yourself.
What?
Didn't you just spill?
Yeah, but I didn't spill champagne.
Yes, you did. It was minute 13.
No, I didn't actually spill it. I just bumped the thing. I didn't actually spill it.
Well, I assumed because...
fair assumption.
It's a Davison way.
Yeah, Jack, when you watch Discovery or any science fiction, this is what you gotta do.
Okay, everybody take a drink. I will I will ship you a penny. If you can, a penny.
What, do we have a penny?
We do in a jar.
Oh.
If you can tell me what reference that is. Brandon, you can
No,
answer this question.
Brandon is ineligible. And by the fact that it was a reference, I'm pretty sure...
Star Wars or Lord of the Rings.
People can figure it out.
I will need your address. Because I'm going to be shipping out...
a penny?
I'll be shipping a penny.
You can't send money by mail.
Why can't you?
I don't know. It's not good to send money by mail.
I used to get
$5. It could get stolen.
I used to get $5 from my grandparents all the time for my birthday.
And no, the Q Star came to the Discovery. All right. Well,
You're in charge.
I know. Am I though? All right. Well, James Webb Space Telescope. It's out there, and it's doing its thing. And in about 6 months, it's going to start doing more things that are going to enlighten us and expand our view of the cosmos. And I'm excited.
And we're going to have cosmos as we expand our cosmos.
And I'm very excited. I'm very happy that I'm aware now of space and astronomy. I think most people, it's just like in a background thought of existing in a solar system, and what the planets are, and then it grumbles about Pluto should be a planet, blah. It's a dwarf planet. Get over it. Fuck off at this point. I am, but having astronomy brought to the forefront of something I am passionate about and excited about has really changed my perspective on everything, and I'm very happy that I'm aware of that, and aware of just a larger universe out there, essentially, because I think it's important. I think what most people don't realize is that James Webb Space Telescope cost $10 billion. $10 billion. That's a lot of fucking money.
Well, in our
lives, but that is what money should be spent on, because it is something as simple, or rather the most complex and hugest engineering feat of humanity. That is something that helps advance us and grow our ability to exist and survive in a harsh world and a harsh universe. Like, I hate to break it to you, but we weren't made to be here. We evolved through many iterations and many versions of we are today through luck and circumstance. I mean, if that asteroid never fucking hit in Chicxulub and wiped out the majority of these huge fucking predatory reptiles,
lizards,
I hate to break it to you, but you want to be fucking upset at your barista for getting your Starbucks order wrong.
No,
like,
we're
a lot of luck came into this, and the fact
accidents.
that we have now evolved the cognizant ability to then question and think and then develop these things that can help us learn more and understand our place in this universe more. I mean, that is amazing and special and lucky and worth spending our time and money on, even if it fails, even if something bad happens, because it can, because you're dealing with unknowns. You're relying on your knowledge of math and physics and but there are
Engineering, yeah.
and engineering, but the universe is a wild and crazy and cockeyed place.
Right.
That unforeseen circumstances can happen. So it's exciting and it's worth, and it's so much worth just to take pictures of the sky.
Right.
If people are like, oh, that's a lot of money to spend to take pictures of the sky, it's 100% worth it.
I have to say this. If your complaint is that James Webb Space Telescope costs $10 billion and you think that's a lot of money and we should be spending that elsewhere.
Mm-hmm.
Warren Buffett.
Like for the homeless.
Warren Buffett. Oh, the people saying that 10 billion is too much probably aren't saying for the homeless. They're probably saying, oh, we need to put that in military.
How about instead of launching our ass into space, Musk and Bezos or whatever, I don't know, help fellow mankind. We don't need you to fucking go to space.
Warren Buffett, his the amount of money he has is 10 James Webb Space Telescopes.
That's a lot of money that can go to good things.
If your complaint is that James Webb Space Telescope is too much, what is your complaint about Jeff Bezos, about Warren Buffett, about the Tesla dude? What's his name?
Musk. Elon Musk.
Elon Musk. I was going to say Mark Cuban, but I knew that wasn't right. And so 10 billion really is not a lot. So yeah, 10 billion is not a lot.
Nowadays.
Like you were saying, it's worth it.
Change.
10 billion is worth it to be able to, understand the universe.
Mm-hmm.
And you say take pictures of the universe, but there's so much more. It's deeper.
Yeah, plus not to mention the fact that what we benefit in new technologies and, things that we can utilize here on Earth from space exploration. Like you wouldn't have a ton of medical equipment and, the things that you use today from it. Jack had to leave. He's got to go off to his rehearsal for grown-up story time. But he was visualizing a T-Rex barista.
Isn't this grown-up story time right here?
My mom says, can those little arms reach the glasses?
Oh, a T-Rex.
Kinda. You know what? They're probably on like a chain.
No, they have the little. What's the little thing where you?
The little claw thing.
The little claw.
You can just.
You just go like that, and it just picks up your drink.
Imagine a T-Rex in a top hat, or just.
That makes me think the alien. YouTube video.
The alien with busting out the stomach and come on my heart bladder, come on my whatever it is.
My baby.
All right, well, lots of things to look forward to. We're excited. We hope you're excited. And I guess in 6 months, we'll be covering what's been going on and what kind of science things are going to start ramping up with James Webb.
Well, we should, because it would have made one complete orbit around L2.
And we will do that.
Well, so we know what our July episode is.
It's an angel. Yeah, so we know what July is, but tune in next time for...
we don't know.
We don't know. It'll be something space-related, and we'll be drunk for at least
the hangover.
But thank you all for joining us. Follow us on all the things at Drinking Cosmos on Twitter, Cosmos with Cosmos on everything else. We hope you had fun. Be safe. I'm glad it was a wild ride. It was a very
wild ride.
You're welcome. That's what we're here for. That's the whole point.
So cheers.
And we will see everybody next time.
All right, goodbye, everybody. Bye. Stay safe. Wear the mask.
Love you all.
Stay healthy. See you in 2 weeks.
Bye. Peace. All right.
Are we done?